Okay, so welcome to another video. We're going to solve another problem in confidence interval, and then we will solve the problem 8.9 in the book of Ken Block. The reminder, guys, please don't watch the video, study with the video. If you already watched the video, please pause the video and then try to answer on your own. Okay, so let's start. Okay, this is a very long problem, and then some problems, some students will be mental block if the problem is very long. So in this case, guys, pause for a while and then do not read the problem. Try to convert this problem into a framework, into our Doraemon framework, for us to easily visualize the problem. Okay, so this is the value, and then let's try to put our framework here, and then let's start reading now. So a community health association is interested in estimating the average number of maternity days women stays in the local hospital. So a random sample of 36. So 36 is that's our sample size who had babies in the hospital during the past year. Okay, the following numbers of maternity days each woman was in the hospital was rounded to the nearest day. Use this data and a population standard deviation of 1.17. So that is 1.17 to construct a 98% confidence interval. So our alpha in this particular case is 0.02. Why is that? Because the decimal equivalent of 98% is 0.98. 1 minus 0.98 is 0.02. Okay, so we have to construct a confidence interval to estimate the average maternity stay in the hospital for all women. So we are talking about the population here who had babies in this hospital. But the question is, we still don't have the point estimate. So using this data here from the average, so we are simply add this one and then divide it by 36. Okay, and then we can directly get the mean. This is the mean of this entire sample here. Okay, and then using the sample mean, using this point estimate, we are going to now to predict, or we are going to estimate the mean of the entire population. Okay, so that's 0.02. Again, in confidence level, we have to divide this one to 2. That is why the value here is 0.01, and then the value here is also 0.01. And then we have to take a look at the z-table, because this problem is talking about the z-score. So 0.01. Okay, let me pause and then let's find the 0.01. Okay, so the value here is this one. We can approximate this one, the 0.01. So that is negative 2.32. If we're going to take a look at our distribution plot here, negative 2.32, approximately negative 2.32. Okay, so we have to use this formula here and then just directly plug in the values there. And then the equation looks like this, and then we simply solve this one, and then this is our confidence interval. So we can say that using this point estimate here, that 3.31, we can say that the population mean, we are 98% confident that the population mean ranges from 2.86 to 3.76. Okay, good luck and God bless.